So hi there, so today we're going to talk about floating point and integer. So it's performed by Petherbridge M, and I welcome you to my PowerPoint presentation. So the first of all, we're going to talk about computer memory and data representation. So computer uses a fixed number of bits to represent a piece of data, which could be a number, a character, or other. An n-bit storage location can be represented up to 2 n distinct entities. For example, a 3-bit memory location can hold one of these 8 binary patterns. Hence, it can be represented at most 8 distinct entities. You could use them to represent a number from 0 to 8, numbers 8881 to 48, that characters A to H. So integers, for example, can be represented 8, 16, 32, and 64 bits. You as a programmer get to choose an appropriate bit length for your integers. Your choice will impose constant or the range of integers that can be represented. Besides the bit lengths, an integer can be represented in various representation schemes, unsigned or signed integers. That's your choice. An 8-bit unsigned integer has a range of 0 to 255, while 8-bit signed integer has a range from 128 to 127, both representing 256 distinct numbers. So it's important to note about that the computer memory location merely stores a binary pattern. It is entirely up to you as a programmer to decide on how these patterns are to be interpreted. For example, 8 binary patterns can be this number, as you see, 0100, 301B can be interpreted as an unsigned integer 65 or ASCII character A, or some secret information known only to you. In other words, you can have first decide how to represent a piece of data in a binary pattern before the binary pattern makes sense. So interpretation of a binary pattern is called data representation or encoding. So first we're going to talk about integer representation, and in this picture you can see integer number line. So it's also negative and positive numbers. 0, as we know, is neither positive nor negative. So integers are whole numbers or fixed point numbers with a radix point fixed after the least significant bit. They are contrast to real numbers of floating numbers that we are going to continue to talk later on, where the position of the radix point varies. It's important to take note that integers and floating point numbers are threaded differently in computers. They have different representation and processed differently. So computers use a fixed number of bits to represent an integer. The commonly used bit lengths for integer, as I said before, it's from 8 to 64 bits. Beside the bit length, there are 2 representation schemes for integers. Unsigned integers, as I already said, can represent 0 and positives. Signed integers can represent 0, positive, and negative integers. So, and let's come to floating point numbers representation, and in this picture you can see those decimals. So what is a floating point representation? A floating point or a real number can represent a very large or very small value. It depends on the degree. It could also represent a very large negative or a very small negative number. Also, is up to the degree of the number, as well as 0 as illustrated. A floating point number is typically expressed in a scientific notation with a fraction f and the exponent e of a certain radix in the form of, we can see that small formula that can represent it. Decimal numbers use radix of 10, while binary numbers use radix of 2. Representation of floating numbers is not unique. For example, the number 54.66 can be represented neither ways of those three. The fraction part can be normalized. In the normalized form, there are only single non-zero digits before the radix point. So it is also important to remember that floating numbers suffer from loss of precious when represented with a fixed number of bits. Example is 32 and 64 bits. This is because there are infinite numbers of real numbers, even with a small range that varies from 0 to 0.1. On the other hand, an n-bit binary pattern can represent a finite 2 to n distinct numbers. Hence, not all the real numbers can be represented. Their nearest approximation will be used instead of result in loss of accuracy. It is also important to know that floating number arithmetic is very much less efficient than integer arithmetic, so please remember that. It could be speed up as so-called dedicated floating point coprocessors, but this is a pretty much other theme to talk about. So now I want to explain the real difference between integers and floating point values to you to be clear what are they. So let's start. So in a floating point value can be a whole number. Why bother using integers in your programs at all? Why cannot we do that? The reason is that floating point value is integers are handled differently inside the computer. So integer exists inside the computer as a true binary value. For example, the value 122 is stored in a modern computers as a 32-bit value. We can see that on this picture. The sign bit determines whether the value is positive or negative. The rest of 31-bit are used to represent the value. So if a floating point number, however, cannot exist in the computer that uses binary, don't be silly, of course. So the floating point is cleverly faked using the same 32 bits. A floating point value 13.5 might look like this. So it's also possible. First comes the sign bit, 1 for negative and 0 for positive. The exponent is used with the mantissa is a complex and mystical manner to fake floating point values in binary. So the bottom line is that it takes more work for your computer to figure out binary problems like floating point that it does for the computer to work in integers. So to conclude up all our PPT, I could say where it is possible, use integer values whenever you do any kind of a work in your computer. Use the floating point numbers only when it's necessary and you really need to do that. So I would like to thank you for your attention. So like, comment, share, and subscribe.